Hello everyone and welcome to my session about Firebase and the library FB4D. In this session I would like to give you an introduction to the services of Firebase and show you how you can use Firebase databases and other Firebase services from Delphi application with my open source library FB4D. As first, I will start with an overview of Firebase and where you can get the FB4D library. Then I will show you how easy it is to install and use the pure source code library FB4D. As next, we will create the project in the Firebase console and I will demonstrate the functionality by using the intro demo application, which is included in the project. So, let's start with the introduction about Firebase. But first, I would like to introduce myself briefly. I've been a software developer for 13 years. Today, I work as lead developer and software architect. I have experience from assembler to C, C++ to Delphi. I have been working as a freelancer since the 90s, mostly for medical technologies. I built systems for patient monitoring and later I built laboratory machines for virus detection based on PCR for Roche Diagnostic. And I'm the author of the library FB4D. Let me start with an introduction to Firebase services. What is this cloud solution from Google all about? Firebase, as a collection of web services, is designed for mobile apps and web apps, but not for desktop application. Google offers a good SDK for Android, iOS, and JavaScript for web. The tools covers the entire development life cycle for application development. I only focus on building applications. Firebase Auth for the authentication of users is the first service I will explain in detail. Firestore is similar to MongoDB because both uses a documented-oriented data model. But the database Couchbase Lite is even more similar to Firestore, but for local installation only. With cloud storage, you can build your own Dropbox system, for example, to deploy new releases. Cloud functions are server-side functions that are written in JavaScript or TypeScript and can be called from client applications. The ML Kit offers server-side functions and client-side functions based on the TensorFlow Lite library. FB4D offers an interface to the server-side ML Vision function. Next, I would like to show you briefly with two slides where my FB4D library can be obtained from. FB4D stands for Firebase for Delphi and is hosted on GitHub. I know that writing code alone is not enough. That is why I created a detailed wiki and I also maintain a discussion forum. If you like the library, please give a star to increase the range of visibility. You can also get the FB4D library from Gedit, but most of the time there is not the last version on Gedit because Embarcadero has not yet built in an automatic system for update the libraries from GitHub. With the exception of hosting, FB4D supports all Firebase built services. Of course, not all functions are available as with the original SDK, but this is my goal. I'm currently working on the integration of Gemini AI, which brings strong NLP functionality. I will demonstrate this future interface at the Econ 28 in November in Düsseldorf, in Germany. The library uses Firebase REST API internally and builds on long-running HTTP calls to be informed about database changes without the need for polling the database. It is a cross-platform library which supports all frameworks and platforms of Delphi. It is suitable for GUI applications as background threads and services. Use the correct call method, synchronous for threads and asynchronous with callback routines for GUI forms. There is a separate interface for each service provided. I have built a class factory that offers an easy access. The integration of the library is trivial. You only need to include the source folder in the project and set a compiler condition. So, enough theory. Let me start with the first Firebase service, the Firebase user authentication. Here in this folder, I have already downloaded the FB4D project from GitHub using my favorite tool, Tortoise for Git. Now let's go into the subfolder for the sample projects and let's open the FB4D sample group within Delphi. I recommend to do your first steps with the sample application demo 4D. I will show you with a short overview the rest of the application later. This cross-platform application provides a good starting point for getting started with Firebase. During the preparation of this session, I have tidied up and revised this important application. The main form of this application now contains a separate frame for all Firebase services. These frames are placed in tabs in the main form. This helps to keep a better overview than in the past, because the last version of this form has contained 3,000 lines of code. The application also includes all source files of FB4D directly into the project. This helps to inspect the source files of FB4D and get fastly familiar with this project. When you start the application for the first time, you must first enter a project ID and the web API key of your Firebase project. Later on, this information is saved in an ini file and you don't need to re-enter this basic data every time when you start the application. You will also not show this detail until you press the button Firebase Project Settings. But first we need to set up our own Firebase project in the Firebase console. For this purpose, I have added two link labels. With the one on the left side, you can directly open the Firebase console in your browser, while the one on the right side is depending on the selected tab and opens the Firebase console for this service in your browser. But now let's start the application for the first time. In the caption, you see the version of FB4D library. So let's open the Firebase console in the browser and we will create a new Firebase project for this demonstration. I have already 2 active projects linked to this Google account, so I had to blur the details for this video. Let's create a new project step by step with this wizard. I will call the project CodeRage24. We don't need to enable Google Analytics. So the project is now ready. Let's go into the project settings. This is the project ID which we need, but the web API key is still not existing here. For this purpose, we need to add authentication services. Let's start with the authentication services. Here you see the methods for authentication, which is supplied by Firebase. We use email as primarily. Then we add also anonymous. All the other providers like Google, Facebook, Twitter or X and others, GitHub, are currently not supported by FB4D. Now let's go back to the project settings and you can see where we have already the web API key. I can copy now the project ID and paste this ID into the corresponding field into the demo app. And I do the same for the web API key. Before I explain the details of the authorization, I will restart the demo app. After this restart, the Firebase project settings are collapsed now. Now let's start using the authorization service. First, we need to create a user. In contrast to a classic desktop application, as we know it from the past when using SQL databases, in the new mobile world, the user is usually created by self-registration. On the other hand, it's also possible to create a user in a classical way by the administrator. However, I need to use the button Sign Up New User to do this. Therefore, I enter an email and a secret password. In terms of secret password, this password is written in plain text in the ini file in this demo application. Please never do this in a real application. Customer password should not be saved, neither encrypted nor unencrypted. So I enter here a fictitious email address and a password for testing. Then I press the sign up button and we see the new created user. Before I will explain all this detail, I show you the new user created in the Firebase console. Here, this is the user ID. Sign up not only creates the user, but also logs them in. Here you see the user is newly created. But the email is not verified yet. If you would like to have a verified email address, you can instruct the authorization service to send an email with a verification link to the user's email address. Next time you log in, this flag will be changed. Here we see the current user security token for the created user ID, which is later sent to other Firebase services as an authorization bearer in the HTTP header, in order to get access with the user ID. Each generated token has an expiry time after which a token is no longer valid. Fortunately, the FB4D library automatically renews the token when it expires. To do this, it automatically sends the refresh token to the authorization service and retrieves a new token. Before I show the next important function, the login of a user, I restart the demo application. And you see the previous created user is stored in the ini file for you. So I press now the login button, and here we get a new token with a new expiration date, with a new refresh token, and all the details. I do not like to explain all the details with the GVT claims. I refer to the wiki of the project to read all these details. Here you are able to change a display name, the email address, to set a new password, to set a photo URL or an avatar. But all these functions are not that important that I will show you. Here you can also delete a user which is logged in. But with this function you cannot delete a user from another user. It's only possible to delete a user which has signed in by themselves before. Before I show you the code behind the functions, I would like to point out another new function that I added last week. The logo in the top right corner is not only nice, but a click on it opens the browser with the project wiki on GitHub. When the project settings are expanded, the Getting Started description for this demo application is displayed. In all other cases, the wiki reference page of the current tab is shown. So here we see this is the constructor to get an Firebase authentication interface. This is the function sign up with email and password as in the synchronous variant. And there is also an asynchronous version of this function. So let's show that. First, I close the running application. Then we move to the frame of the authentication service. And I show here the function sign up with email and password. Before we can use this function, I have here check and creation of this authentication class. It is here we create the class and we assign it to an interface in order that we don't have to free that interface at the end. Let's jump back to our function, because here we have with the asynchronous method two callbacks. One is the positive response, one is the error situation. Here on user response we are properly signed in, and we have here in this circumstance created a new user. In the display user method, the details of the newly created user are displayed, for which we have received an Firebase user interface. First, we show the user ID, UID, and then we have several flags which we interpret here. That's all for the moment. At this point, I would like to point out another feature of FB4D in connection with the authentication service. Since the self-registration of users is a frequently used workflow in mobile applications and can also be used by desktop applications, I have created a frame for this workflow as a reusable GUI pattern. This application uses this frame from the GUI pattern folder. Unfortunately, there is not enough time to explain the details of this workflow in detail, but I would like to refer you to the wiki, which explains everything well. Here there is a description of this self-registration workflow. This diagram shows what happens in detail. It checks first if the user is already registered. If yes, we log in. If no, we sign up. And there are a lot of different options which is considered in this functionality. So this is all what I can show for the authentication service. The startup company Firebase Incorporation launched the real-time database in 2011 and was acquired by Google in October 2014. Under the new management, the second database, Firestore, was developed, which works better with structured data. Today, however, both cloud databases have their advantage and disadvantage. The real-time database stores its data in a large JSON object. It's ideal for many read access with fewer write and change accesses. The data is not stored in a highly structured manner. The database is suitable for small data volumes. The Firestore database, on the other hand, stores data in documents in hierarchically structured collections. It's suitable for high frequent read access and few write access and for infrequent changes. It offers limited query functionality and also write and read transactions. As a distributed database, it scales optimally and grows with the number of users. In contrast to the NoSQL database, the benefits of classical SQL databases are still there. It is suited better for ACID, which also be shown here. The keyword ACID means atomic consistency, isolation, and durability. On the other hand, it's more difficult for SQL database to increase the number of accesses by users, as is usually the case with cloud application with a growing number of users. It's always important to use the right tool for its purpose. The real-time database is ideal for chats and games, but also for simple real-time collaboration tools. This database is also suitable for rapidly changing measurement values for production systems. Firestore, on the other hand, is more suitable for e-commerce applications that requires real-time change for the inventory. Even complex network applications such as a Slack or a document editor or project management systems can be built with this database. It also seems important to me to point out that complex database applications such as an ERP or a CRM but also banking systems are still better solved with SQL databases. The real-time database has its own JSON object as a setting, where access rule can be defined per node. Read and write rights can be defined differently. Validation rules can be written to ensure a minimal data structure. Individual fields can be indexed for faster search and sorting access. Enough the theory. Let me start with setup the real-time database. First, I start the demo application again and sign in with the previously created user. Then I change to the type of the real-time database and I open the Firebase console in my browser for setup the real-time database. At this point, Google asks me if I'm sure I need the real-time database because they are trying to redirect more users to the newer database. Nevertheless, I start the creation with a real database. Here I can select where my database should be physically stored. Another question clarifies which access rules I want to start with. To avoid having to deal with the complex access rules right from the start, I leave access open for 13 days. But it's clear that such a setting would be a security risk for a productive database. Now the database has been created and I still have to copy the database link for my demo application. I will enter this here. The first thing I want to do is write the value into the database. To do this, I choose the put method. I write the no-name first value and the test data. I add that to the node and I use the put node asynchronous method. Now I would like to view the result in the console. Here we see the value. Yet I can show the functionality of the get asynchronous method. Here we see we get this value. Normally we don't write the node directly into the root, but we use a pass. For the second attempt. Here we see the second value. If we only want to write a part of a node, we need the method patch. So I switch to the patch type and add a third value name pair by calling the put method in the asynchronous version. Let's see the result. To understand the patch operation better, I will repeat the put. So you see the third value is removed again. As next, I would like to show you another write operation which is also very useful. It is the post operation. It creates a new node with a random ID. I use the asynchronous variant and we check the result. Here you see we have this automatically created ID and here a value, and I do it once more with another data. So you see we have different IDs for different data. The delete function is easy to understand. That is how quickly a node can be removed again. The entire test path is deleted. Finally, I will show you the database listener. A listener is installed with the start button for the current database path. I can install several listeners running in parallel for different paths. With the previous shown operation, I'm able to create new nodes. I do that a second time. And here in this line, you see the reported changes in the database. We will inspect that. And we will check what we get. Here, same. And I can stop the listener again. I have to select it from the list and stop it. On server variables, there is only one functionality, get server timestamp, which informs me about the current timestamp of the server. That's all functionality for the real-time database. Now I will explain some theoretical aspects of the Firestore database. One Firebase project can contain more than one Firestore database. The documents contain JSON object with a set of predefined data types. Each document can contain a different structure. There is typically no scheme, but rules can be defined. On the other side, often the documents of a collection has the same structure, or at least main elements are the same and optional elements are only contained in some documents. Document IDs are typically randomly generated character strings of a size of 20 characters. Attention! Field order in the document is not defined and varies between each read. This doesn't matter if you use the method of FB4D to get the fields. This is an example of a Firestore database for an online bookstore. In the collection Books, we have a list of documents describing a book. To limit the number of read accesses for the master view, it would be better to integrate an abstract out of the preview document directly into the book document, and also the last 3 reviews. This leads me to inform about the paradigm shift in NoSQL database. Redundancies are no longer avoidable and are tolerated. For this purpose, the structure should be set up in such a way that fast and few readings are sufficient to save costs. So let me create our first Firestore database in the console. For this purpose, I change to the Firestore tab and open the Firebase console for the Firestore. Here I create a new database. I can select again the location. I set up the starting rules for the access. This is our new database with the name default. Let's go back and let the database ID empty for the default database. I set up a collection test call and create the document. And let inspect this new document. Here it's empty. This is the document ID, which we also find here. So I insert a simple document by choosing this combo box and back, and we have a document with one test field with this simple text. There are two ways to read or write the content of a document, either by accessing fields via the JSON object of the document, taking into account the data structure. This older approach is still used in the demo application. Here we see the field of a type string being written to the document of a simple document. And here we see a real document with a much complexer structure. However, there is a newer, simpler way with a document to Delphi object wrapper that simplifies access by using the TTI. Only one class needs to be derived from the Firestore document. This approach is shown in the sample application FS object to doc test. This is the class which is derived from the Firestore document. Here is the class for writing. The document is created with the save object to document method. For reading, we need the load object from document. It's more simple than the first, older approach. As next, we can patch this document and add a second field. As next, I can demonstrate to get this document. This is the result of get. And we can also delete again this document. For the next example, I choose here a complex document, which creates me a document with all field types. You see, we have a simple real field, a reference field to another node, an integer field, a string field, a geolocation point, an array of 4 with strings, and the fourth is a map. The map contains another map with a time, with a string, with a boolean, with a double, with a string, with a geopoint, with a null. How does this look? Here in the console. This is our array. This is a bool. Here we have a bytes as a blob. Perhaps I can show that a little bit better. A string, a subarray, time, another submap. Here we have a null. We have real, we have a reference, we have strings. And even as explained, if I use get once more, the order of the fields are randomly. Before I can show you the query, I will delete again this document and clear the log and check the results in the console. As next, I would like to demonstrate the run query. For this purpose, I need to create at least 5 documents with a test int field which is randomly created. This is our first. Next document. Here we have the 70. Let's do it faster. So we should have now 5 documents. Let's check that. I remove the document and I make a get. Then we see, okay, we have 6 documents, but so far that's fine. We go to query. We set a minimal value for the query. And you see here we get 3 documents if we have a filter for test int higher than 50. If we reduce this limit a little bit, less, so we have 4. We have 1 more. That is how the query is working. As next, I want to demonstrate the listener. I set it for the same collection as we have used before. So you see all our installed documents came back, and if I add a new one, the 99, you see we will get immediately this document back. I can stop it again, and here you see with this new icon that the listener is still running. Now it stopped. Finally, I will talk briefly about transactions. There are 2 types, read transaction and write transaction. The first are used in case where we want to query multiple documents at the same time, while write transactions allow multiple documents to be written to the database atomically at the same time. Let's demonstrate the write transaction. For this purpose, I will create 2 new documents. And here you see that the document is not written yet into the database. I will create another, add it, and the database will be written into the database when I press the commit. That's all about write transactions. I have already created the storage in the Firebase console, and now I only need to add the bucket name into the demo app. First, I want to upload a photo to the store. For this purpose, I choose a photo from this year's Delphi Summit in Amsterdam. We check the result in the Firebase console and can see this photo is uploaded properly. And finally, we want to download the photo again. Download asynchronous. So you can see the photo is downloaded. Perhaps also important to know, there is no get directory function which you can read the contents of the storage. That is why you have to write references to the files in the storage in one of the 2 databases in an application. That's all about the storage. Unfortunately, there is not enough time left in this session to show the other 2 services. I will just give you a brief overview. With the server-side functions, Functions created in JavaScript or TypeScript can be started from a client application. This example shows a function from the unit test. With Vision ML, you can upload a photo from the storage, or you can upload an image in GIF or TIFF format, or even a PDF and analyze it with various functions and features. In addition to text recognition, this image processing system also offers object recognition, face recognition, landmark detection, and much more. To use this function, however, you need a paid subscription with a credit card. So I have to come to the end of my session. I would like to share a few general thoughts about writing open source. I started this library in a large customer project, and I had at that time a sponsor for the main development. I will be happy to help you with any questions or problems in getting to know this library. On the other hand, please understand that I cannot work for free on your project. If you need support, I'm happy to offer you consulting and collaboration in your project. And for cases where you have a commercial application with this library, think about the sponsoring, because this also secures your development investment. This is because the Firebase API is constantly being expanded and updated and require maintenance. And also for small application, don't forget to give the GitHub project a star if this library helps you.